In the vast darkness of space, our Milky Way slowly turns. Among hundreds of billions of stars, one question echoes: where did we come from? Our story slowly drifts inward, from the quiet edges of the galaxy toward a small, unremarkable star. Over billions of years, this pale world below will change, burn, freeze, and awaken long before a single human ever walks its surface. In the newborn universe, only the lightest elements existed: hydrogen, helium, and traces of lithium. Gravity gathered these gases into the first stars, titanic blue-white furnaces, where simple atoms were fused into carbon, oxygen, and beyond. When these ancient giants died in supernova explosions, they forged heavier elements: iron, gold, uranium, flinging them across the galaxy as stardust. From the dust of countless ancient stars, a young Earth emerges, a molten sphere wrapped in a choking, poisonous sky. Asteroids the size of cities slam into its surface, oceans of molten rock boil, and a dense haze of carbon dioxide, methane, and steam seals the world in suffocating heat. As Earth slowly cools, scalding rain condenses into vast, newborn oceans, steaming beneath a thick, poisoned sky. Beneath the waves, volcanic vents gush mineral-rich water over 300 degrees Celsius, turning the dark seafloor into a chemical crucible. Around scalding hydrothermal vents, simple molecules swirl and mix through mineral-rich alien seas. Here, carbon, hydrogen, nitrogen, and sulfur collide on jagged mineral surfaces, forming the first fragile organic chains. Driven by heat and pressure, these chains fold into more complex structures: primitive amino acids and lipids, the seeds of biology itself. In these restless seas, fragile molecules stumble into a momentous trick. They begin to copy themselves. Encased in delicate membranes, the first single cells emerge, tiny chemical engines powered by Earth's heat and chemistry. Across shallow, ancient seas, sprawling microbial mats carpeted the sea floor, slowly weaving thin films of oxygen into Earth's suffocating waters. Over hundreds of millions of years, these simple colonies evolved cooperation, giving rise to delicate, multicellular bodies drifting through the seas. Around 540 million years ago, the oceans erupt in evolutionary creativity. Within a geological blink, ecosystems blossom, with armored trilobites, soft-bodied predators, and the earliest complex food webs. Hundreds of millions of years pass, and at last, life inches away from the oceans onto steaming prehistoric shores. Early amphibians, half fish and half walkers, stalk insect-laden river banks beneath towering lycopod forests and oxygen-rich emerald skies. For over 150 million years, reptiles ruled the continents, seas, and skies in staggering reptilian forms. Then, about 66 million years ago, an asteroid 10 kilometers wide struck Earth, unleashing firestorms, tsunamis, and a global night. 3/4 of Earth's species vanished, but in the emptied niches, small mammals began to multiply and to diversify. In the dinosaurs' absence, small nocturnal mammals emerge from hiding, seizing empty niches. Within a few million years, they diversify into insect eaters, climbers, and gliders, their warm-blooded bodies fueling restless activity. In humid Paleocene forests, the first true primates appear, small and nocturnal among flowering branches. Grasping hands and feet curl firmly around bark, while forward-facing eyes gauge distance with new precision. In Africa, the world of our ancestors begins as deep, shadowed rainforest, dense canopies trapping moisture and heat. Over millions of years, shifting tectonic plates and cooler global climates thin the forests, opening vast mosaics of woodland and grassland across the East African Rift. By around 7 million years ago, open savannas stretched beneath vast skies, scattered acacia trees casting short shadows over shimmering grass. In these shifting African mosaics, early hominins like Sahelanthropus venture out from dappled woodland shade toward the open savanna edge. A few million years later, Ardipithecus carefully balances on gnarled branches and then steps upright onto the leaf-strewn forest floor, midway between the canopy and the plain. To walk upright, our ancestors' skeletons had to be completely rebuilt from the ground up. A shortened, bowl-shaped pelvis gently cradles the organs, while an S-curved spine helps balance the head above the hips. In Tanzania's Litali Ash, 3.6 million-year-old footprints show a narrow gait and an aligned big toe, unmistakable marks of habitual bipedalism. On the open East African plains, Australopithecus afariensis walks upright in small family groups, their silhouettes wavering in the heat. In a rare volcanic drizzle, their bare feet press into wet ash, leaving the Litali footprints, fused big toes, deep heels, and a clear arch, evidence of committed bipedalism 3.6 million years ago. These early hominins still carried small, ape-sized brains, yet their bodies were changing in remarkable ways. Long, powerful arms still gripped the tree branches, while shorter, stronger legs and arched feet carried them efficiently across the open ground. Around 2.4 million years ago, a new figure appears, Homo habilis, the handyman of early humanity. With more precise, agile fingers, habilis selects river cobbles and strikes them together, chipping sharp flakes for cutting into scavenged carcasses. On the open savanna, carcasses left behind by larger predators became crucial opportunities for early Homo. Small bands of Homo habilis approach cautiously, using simple stone flakes to slice meat and crack long bones for hidden marrow. Coordinated watchfulness, shared food, and ever-sharper tools wove tool use, cooperation, and a richer, meat-heavy diet into a single survival strategy. Around 2 million years ago, a new figure strides onto the African plains, Homo erectus. With a brain approaching 900 cubic centimeters and long, narrow limbs, this species walks with an easy, human-like stride across vast distances. On a windswept African night, early Homo erectus gathers around a fragile circle of captured flame. The flickering glow pushes back predators' eyes in the darkness, extends their day, and opens a new world of cooked food and shared stories. Over 1 million years ago, Homo erectus began pushing beyond Africa's savannas. Generation by generation, their journeys traced new paths into the Middle East, across Asia, and deep into Europe. Over hundreds of thousands of years, new branches of our genus slowly appear across the Old World. In Ice Age Europe, stocky archaic humans, the ancestors of Neanderthals, adapt to bitter cold and dark winters. Far to the east, their Denisovan cousins occupy high Asian plateaus, while other archaic populations persist in Africa's forests and savannas. Around 300,000 years ago in Africa, anatomically modern Homo sapiens appear, bones almost like ours, yet not quite. Subtle shifts in skull shape, framed softer faces, brows less heavy, capable of a wider range of fleeting, complex expressions. Today, our shared origins are traced, not in bones, but in DNA. Comparing genomes from people worldwide, geneticists reconstruct a branching family tree, converging back to small African populations 200,000 years ago. Around 60 to 70,000 years ago, small bands of Homo sapiens began leaving Africa, following coastlines and river valleys into the wider world. As they pushed into Ice Age Eurasia, they entered bitterly cold steppe and boreal forests, lands already held by Neanderthals and the elusive Denisovans. Sometimes they competed for game and shelter, but they also met, exchanged tools and genes, leaving Neanderthal and Denisovan DNA carried today in billions of modern people. When Homo sapiens met Neanderthals and Denisovans, they did not just compete, they interbred. In our DNA, these encounters left small traces, about 1 to 3% in many people outside Africa, quietly shaping our bodies and minds. Borrowed genes for immunity, fat storage, and coping with cold, subtly altered cheekbones, noses, and skin, fine adjustments that helped us survive new worlds. Then an unprecedented spark appears. Humans begin covering cave walls with swirling herds, handprints, and star-like signs. They carve tiny figurines, string shells and teeth into ornaments, and breathe music from hollow bone flutes, over 40,000 years ago. With language, our ancestors could share detailed memories of distant water holes, dangerous cliffs, and seasonal animal paths. Myths and shared stories bound hundreds of strangers into tribes, creating invisible nations in the mind that could plan, cooperate, and remember across generations. As the Ice Age loosened its grip, some human bands began lingering, where wild grains grew thick, along rivers and fertile plains. By sowing seeds and tending animals, they traded wandering for the first clustered villages, mud brick houses, shared hearths, and the fragile beginnings of civilization. Tonight, city lights flicker softly like ancient campfires scattered across a concrete savanna. In every crowd and every glow, the same restless species still gathers around the fire of its own making. In quiet laboratories, scientists read our story in shards of bone and spirals of DNA. By comparing ancient genomes to billions of modern data points, they uncover recent evolution, new immune defenses, altitude adaptations, even shifts in our brains. In just the last few thousand years, our genes have shifted, sharpening resistance to epidemics like smallpox, malaria, and tuberculosis. High in the Himalayas and the Andes, natural selection fine-tuned blood and breathing, letting some populations thrive on thin air. Elsewhere, new diets rewired our biology. Genes for digesting milk into adulthood spread in dairying societies, while others adapted to starch-rich grains and coastal seafood. From the silence of space, our planet turns a fragile sphere of oceans, forests, and restless cities. Every mountain and shoreline below was once walked by our ancestors. Every heartbeat today carries that same ancient DNA. We are one species on one world, our origins shared, our future inseparably bound to this small blue home. From a single ancestor on the African plains, every face on Earth inherits the same fragile, extraordinary story. Our genomes still whisper of ancient migrations, extinctions narrowly avoided, and adaptations that bind 7 billion strangers into one evolving family. What we become next, on this fragile planet or beyond it, will be written not by our origins, but by the choices we make together. The story of humankind is still being written. So keep asking, keep searching, and keep exploring where we came from, and where we might yet go.